Okay, in the last two videos, we talked a little bit about the difference in diagrams, and we went over the power. We went over these tables with the fuses and the transformer connections, the variable speed blower, the transformer. So we're going to move on. If you think I'm taking way too long and giving you way too much detail, I'm doing that on purpose. I want you to know exactly everything that I see when I look at this in as great a detail as possible. If this takes me a year to explain, I'm going to keep on going, but I know it won't take that long. But so we got to this point here. We've got the 120 volt power coming out here. We talked about the only three-phase device or component in this boiler is the combustion blower. So everything else is fed from this either 120 or 24 volt circuit. And you'll see this is actually on page 2. So the 120 volt comes out, terminal number 1. Here is the control power switch. Now, when you look at the control power switch, you see that it has a dash line, and here's a number. Okay, the number here is going to indicate the number of the wire marker that's on that wire. It's going to be wire number 1. Here's wire number 3. And of course, wire number 1 goes to terminal number 1. And you will see this. I'm going to scroll down to the very bottom of the drawing, and you'll see here that if it's a box like this, it's boiler wiring. That's actually a boiler wiring terminal. And the dashed line here shows that it goes to the indicator panel. So I'll scroll back up, and I want to show you where the control panel is in your menu items for the triple flex boiler. Here is the triple flex IOM, installation, operation, and maintenance manual. And I made a note here that on page 19 is where you will find the control panel. So right here, if you're standing in front of the boiler, this is the display, touchscreen display. We'll talk about that in a future video. And 6 and 7 right here, those should be the switches. When I scroll down here, it says that 6 is the boiler on-off switch. So the boiler on-off switch right there, control power, and physically on the boiler, it is located right next to the touchscreen display. Just for reference, as I scroll down, when you open up the door, on the back side of the door, this is the actual control panel. Right here is your control transformer that we talked about, and right here is the actual Honeywell Sola electronic controller, the microprocessor based controller that controls all the sequencing of this boiler. So back to the diagram here. After you turn that control power switch on, we get power from terminal 1 feeding over to terminal number 3. Now you see here there is a line coming off of 1 that does not go through the control power switch. So if you think that this control power switch controls everything 120 volts, obviously it doesn't, because you have something here that is powering before it gets to the switch. And I know this is going from right to left, and typically we look at everything going left to right, but power comes in here, goes out there, power is going in, and we'll get to the where this power goes to and why it is not on the switch. But for now, let's just go down to where terminal number 3, there's multiple terminal number 3s. There could physically be multiple terminal number 3s, but in wiring schematic format, that could be the same terminal. Coming off terminal 3, it goes to R1A, and the designation here is R1A, relay 1A, 7 and 4. So on the relay base, and this is something that on our electrical trainers, I would love to be able to show you how you wire up a base for a plug-in relay and how you look at these terminal numbers and decide where you're going to make the connection. But that's actually what that shows. And relay 1A, normally open contact, which that's a symbol for a normally open contact, is what controls the power going from 3 to 32, and 32 is the enable lamp. So it's a green lamp, a green indicator light, and you follow over here, it goes to neutral, which was from our X3, which is a grounded secondary terminal in the transformer. That's our neutral. So this is neutral, 3 is hot. If we close this contact, we turn on this lamp, and we know that the boiler is enabled. Now, where is the coil for R1A? Because if this relay has a set of contacts that has to close in order to show that the boiler is enabled, what actually has to happen for the boiler to be enabled? Well, for that we have to go back to page number 2, and you look over here, coming off of the drawing of the Honeywell solar controller off the right hand side here, you'll see here is the relay R1. Here is the 24 volt neutral. Remember, it came from page number 1, terminal number 2. So here's our 24 volt common. Here is our 24 volt power coming across. So what you see now is, I'm going to scroll down to the next page. Here is terminals 1 and 2 of J8. And if we went back to the SOLA and we looked at J8, terminals 1 and 2, that is our 24 volt device power and return or neutral. So J8, 1 and 2 is the 24 volt power that powers the controller. If we get power on terminal number 3 here, that's when the boiler is enabled, and you'll see from this diagram that J83 is the thermostat input or stat input. We go back to the actual drawing, and you see that between terminal 19 and 20, this is our boiler demand enable, disable, remove jumper when used. And when we get back to the notes, so all the notes at the top of page 1, anytime that you make a physical connection or you like remove this jumper and put in your stop start, maybe you're building an automation system, put in something here, it's up to you to do this per code and make sure that you've done the wiring right. Now this is low voltage, this is 24 volt, this is the 24 volt neutral, and assuming that you had something between here that would open and close, you would then send 24 volts down to the stat input number 3 here, which would tell the controller that we need heat and it's time to fire the burner. But it also makes this relay R1, which going back over to page number 1, closes this contact and indicates with the enable light what the status is that there is a call for heat and the boiler is enabled. So to wrap this video up so that I can get this downloaded and start making quiz questions based on these the first 3 videos, let's talk about this general alarm 120 volt 75 VA tie-in point. When you look at that, terminal number 12 is obviously going to be a 120 volt terminal, and it says that right there. So if you wanted to monitor whether there was any alarm condition on the boiler, you would tie in right here with a relay, and the coil of that relay would be from 12 to 2. We would actually put the coil of a relay power on one side of the coil, common to the other side of the coil, and just like this red lamp, anytime that coil energized, it would close a set of contacts, and that's how we would indicate to our building automation system maybe that there is an alarm. Maybe you want to put a light outside the boiler room door that shows when the boiler is in alarm. So I'm going to use the term for the relay coil here, but the contact that's tied to that relay would be what they call a dry contact. That means that the contact of that relay does not have any power coming from the source, which is the boiler. It is just a contact that is dry and used as a open close switch to indicate that there's an alarm condition. And the reason I mentioned that, when we get back over here, when we were talking about this boiler enable disable, you would typically put a relay contact between 19 and 20 when you remove this jumper, and that would be called a dry contact, and the coil that controls this dry contact between 19 and 20 would actually be from your building automation system, because you wouldn't put 24 volts from your building automation system in with the 24 volts that's coming from the transformer in this boiler. You want to use a dry contact here, and I'll do a little better job of describing what dry contact means when I work on the terminology page for the next set of videos. So dry contact right here to do your boiler enable disable, which makes the relay here, turns on the enable light here. If there's an alarm, we would have a relay here. The relay would have to be less than a 75 VA, which all pilot duty relays are going to be less than that. But the coil of the relay between 12 and 2, and then we would have a set of contacts, a dry set of contacts that we use for an input back to our building automation system for our alarm indication.